Thank you very much. And yeah, hello Moscow. First of all, I must say it's wonderful to be here. I'm really glad to be able to present at HolyJS again. I already did in St. Petersburg, and that was like one of the best conferences I've seen in the past years, and I was totally surprised because I didn't know what to expect before I went to St. Petersburg. Never been to a conference in Russia or that far east. And it was just wonderful, so I'm very delighted to be back again and experience some of Moscow. So first of all, thank you for that, everyone, and thank you for coming to my talk. So, yeah, my name is Sebastian, but on the internet, people usually do know me as ASCII-Disco. So if you want to look up some code, if you're on Twitter and have a question or want to follow me, whatever, I'm ASCII-Disco on Twitter there as well. As a day job, I'm actually dealing with so-called IoT devices. I don't like that buzzword very much because I'm working in the field of smart home for the past, well, it says 6, but actually it's now 7 years where I try to connect a lot of things on a professional level. Sometimes it works, sometimes it doesn't. And the thing is, yeah, so I've been not only professional, but also as a hobby, tinkering with hardware since 2011, so roughly 7 years now. And mostly I did that by using JavaScript. I mean, I have a JavaScript background, I'm a JavaScript developer, and because hardware and JavaScript were really well enabled by using Node.js, I mostly utilized Node.js to talk to hardware. So aside from a day job, aside from the consumer products, I basically do try to wire everything up so I can control it from my computer or mobile phone. I don't know, I have probably like around 130 so-called smart devices. Actually, they're quite dumb at home. And mostly like wiring up those dumb devices, I'm using an Arduino or a Raspberry Pi. One thing you should know though is I don't have any background in electrical engineering. But the thing is, I don't need to. Because nowadays, well, everything can be connected via USB. Maybe adapters that connect to wireless networks like Bluetooth or Zigbee, mobile phones, or even like funny gadgets like this USB rocket launcher. So therefore, as we wanted to talk about JavaScript and hardware today, we're going to talk about the Universal Serial Bus, USB. So before we get our hands dirty with some hardware and code, let's talk a bit about USB basics. And let's start with the history. I do like to start with the history of things because mostly in the beginning things are very simple and all that complexity, well, adds up in the end. So in 1994, USB was created. It wasn't available in any device or to be bought back then. But a group of companies, they just got together and wanted to end our adapter madness. I mean, before USB, we used PS2 ports to collect our keyboards and mice. We used parallel ports to connect our printers, SCSI to connect to external drives, and serial ports for basically everything else. So to bring all that madness to an end, a group of engineers led by Intel found together and, well, started developing USB, like one bus to rule them all. In late '95, the first USB host systems and devices became available to the public, so you could actually, well, go to a store and buy them. But the thing is, they weren't really popular and not very welcomed by the users. So in 1998, Apple decided to be the brave ones. They like to be brave. And they shipped a computer without a floppy disk drive, and more important, without any parallel or serial ports, only USB. And I think that was what really kickstarted like USB and brought it into like, made it available for a wide audience. In 2000 then, USB 2.0, the spec was released. It was improved like in terms of speed and reliability and many other things. But also in the year 2000, we've seen our first integrated USB storage device, a USB stick with the capacity of 8 megabytes. It was a huge thing. But the cool thing is, like, USB after that point was often associated with like bringing data like music or pictures to your friends by using that tiny smart drive, which actually is amazing. That was what USB was like mostly used and known for in the early 2000s. Latest major addition to the specification then came in 2008 and made USB faster and introduced some new plugs, etc. But I mean, as you see, 1994, everything started. USB is quite an old technology already. So later on, when we're going to talk about APIs and how to use it and how to control the devices, all those APIs, they will not seem very web-ish. They will look a bit alien to us because those APIs were designed like not with the web in mind, but with companies that actually construct or build hardware. So, and then with USB, you might probably think like the electrical engineering behind such a sophisticated system must be extremely complicated. But to be honest, it actually isn't. As you see here in this close-up, that is a USB male B plug version 2 point whatever. There are many of those. In the first version of this talk, I actually included a slide with all the different USB plugs, and then I thought, okay, that will confuse the hell out of everyone, let's drop it. But yeah, that's the USB male type B, and I think it's quite good. As you see, there are those 4 pins that are used by the USB connection. Those are actually connected to 4 wires in like the bigger wire behind. Switching to the schematics, we can explain and explore that a bit further. So 2 of those pins are actually used for transmitting data, D- and D+. At first I thought, well, probably one of them is used for incoming data, like D+, and one of them is used for outgoing data. But actually that's not the case. They both transmit and receive data, the same data at the same time. So this is kind of like a hardware security mechanism that enables transport safety. Theoretically, it would work with only 1 wire, but yeah, the spec designed it to have 2 data wires. Then we also have the V-bus. This is where all the power comes from. Up to 5 volts can be transmitted over that wire by spec. And of course, we also have a ground pin, a ground wire. Thinking about USB, you know, when it first was introduced, you probably remember that great Microsoft Windows 98 keynote thingy where Bill Gates plugged in a USB device and there was a blue screen popping up and everything broke. Probably that was a marketing stunt. But USB was introduced and advertised as plug and play. But it often doesn't live up to that claim. So after you bought a device, well, let's say a printer, because that happened to me lately, the way of connecting that device and installing it looks a bit like this. So you search the internet for a driver. Great, you found something that might work with Mac OS whatever you have, or Windows. Oh, okay, we're talking about printers, so I'm not going to talk about Linux anyway. But yeah, next thing you have to do after you downloaded it, you need to install, well, a native application, some kind of driver, some installation program to make that device work in the end. But then you realize, that doesn't work for some reason. So is this device actually supported on my operating system? And then you search the internet again for a driver and think, oh yeah, I've downloaded a driver for macOS 10.8, but I need 10.11, and they're all different. Well, once you have the correct driver, when you install it, sometimes like some scary operating system pop-up turns up and says something like, well, we're not responsible if you, well, have a malfunction and kill your hardware, which, well, often then happens. So after trying to install the new printer, no printers at all work anymore. Well, I had that on Linux, but special case, you know. But yeah, and then you think, okay, now that everything is, well, fucked up, I should get rid of that code and that drivers, and you don't know how, because there's no uninstallation routine, and they're kind of like buried deep into the system internals of the operating system. But does it have to be that way, like, often? I think not. I think there can be like a nicer way to work with USB devices. One that looks like this. You buy a device, you plug it in. We're not living in 1994 anymore. We're all used to smartphones and notifications and everything. So after you plugged in the device, a notification could appear. You only have to click on it. It then opens your browser and a website, and it just works, and you can have fun. That would be cool, right? And, you know, the Chrome team, they thought so as well. And that's why they created WebUSB. WebUSB is a new web standard that enables us to access USB devices directly from within the browser. No need for any server-side code, just the browser. Few facts about WebUSB. First of all, it's only available via HTTPS. Like with all the new platform features, for security reasons, if you want to use those APIs, you either need to use it at your local host system for development, then HTTP is okay. But if you want to put it out on the internet for other people to use, you need to use HTTPS. There's no, let's say, native code needed. So if you ever want to use whatever device you want to use, you don't need to install any third-party software, any native application. Everything is just happening in your browser with JavaScript, as we'll see later. And yes, as described, it's basically real plug and play. Plug in, notification, website, boom, fun. Okay, enough like university-style lectures. I know you do like to see some code now, and well, then let's do that. Let's get to the meat, to the code of WebUSB and how to use it. So the first thing we need to do is, when we want to work with a device and want to write a driver for it in JavaScript, we need to connect to the device. And we'll do that by connecting to its so-called device descriptor. You see here, I mentioned now we're coming to those non-webish alien API terms. Don't worry. So we need to connect to its device descriptor. And usually, a device has only one device descriptor. It provides some information about the device, like the vendor ID and product name and many, many other quite useful things, as you see. So when we connect to a device, in the first request with the Navigator USB request device API call, we can use something called filters. And here we can actually enter some device-specific or vendor-specific codes that later, you'll see that when we connect the device, when the user has to select the device that he wants to steer, that he wants to work with, only the ones we want the user to see will appear. But we'll see that later in a minute, and then you remember, oh, that was what the filter clause is for. And after that, we only have to call device open. Device open, well, then runs all the platform-specific code in the background that is needed to create a session with the device. That was the first step. In the second step, we need to select a configuration. We need to connect and select a config descriptor of the device. So a device can theoretically have many config descriptors, I think up to 127. But usually it also only has one, and this is due to a bug in the early Windows 95 implementation in the Windows standard USB driver, because Windows could only handle one config descriptor per device, so it kind of established as a standard for USB devices to only have one config descriptor. Config descriptors then will measure internally the amount of power that is needed by the device. It will determine subsequent descriptors for interfaces. We'll get to that in a minute. And only one configuration can be used at a time. So once we selected a configuration, we have to disconnect from the device and then reconnect to select another one. If you're, well, now thinking, yeah, config descriptor, select configuration, what is it good for? One example, you probably all have worked with REST APIs. And luckily, usually nowadays, people often version their REST APIs with like v1 / the methods you want to use or v2, so that when they introduce a new REST API, they can have just a new version and the old one keeps working and keeps unchanged. Basically, you could implement the same thing for USB devices with a different config descriptor. So you have the old one, all your old drivers, all the old applications use the old API of the USB device, but then you flash the firmware of the device and want to introduce a new API, a new protocol. You can just then use a different configuration for that and use a different API while the old one is still available. So it's basically like can be used for API versioning like with REST APIs. So as said, next thing we need to do is we need to claim an interface. And again, a config descriptor can have many of those, and probably will. Especially for devices that are multi-purpose, like multifunction devices. You probably often have seen like printers that are also scanners and smart card readers and everything. So if you have such a device, probably one interface will be used for the printing functionality, one interface will be used for scanning, another interface for the SD cards, etc. So this is why we have to claim the correct interface in order to interact with the functionality we want from the device. So we're nearly getting closer to the end. So after we claimed the interface of the device, we are basically now ready to talk to the device, to its so-called endpoint descriptors. And the endpoint descriptors are actually the data, the incoming and outgoing data ports of the device. Again, theoretically, you can have as many endpoint descriptors per interface as you like, but you'll often only use a few of them or even one. Like many devices even only provide one to read data from the device or to send it. So now that we basically did all this boilerplate code to connect to the device, we haven't actually, well, done anything with it. And we actually have 3 different ways to communicate with those devices, 3 different methods. All of those methods come in pairs. One is for sending data, and one is for receiving data. And the first one, and the most easiest, are the interrupt transfers. And interrupt transfers are usually like non-periodic communication, like small and often initiated by the device itself, forms of communication. Also, often by design, they require a specific latency between like the different communication intervals you have with the device. So they're actually quite easy. So once we connected to a device and configured it, the transfer out method only takes 2 arguments. First is the endpoint we're going to talk to the device. So let's say if that's a printer and printing is on endpoint number 1, we'll select that. And second is, well, actually the data we want to transfer to the device. Usually that is done via an array buffer, so in binary. I'll just put some text in there, because actually there are some devices that do work with that as well, but the most use binary data. If we want to read data from the device, we need to specify the length. The length are basically the bits of data we want to, the bytes of data we want to read from that device. So if we call the transfer in method with, again, endpoint 1, we're reading the last 8 bytes of data that is present on a device. Next one is the control transfer method. And those are used and especially nice for small configuration commands, like as they get bus priority, and they do have a well-defined structure. Typical usage for them is like if you think about a robot arm, you would probably have one configuration command you send for beep, getting the arm up, another one for getting the arm down, one for left, one for right. So that is usually done by this short configuration commands used with the control transfer method. Don't worry about those bits right now. Those control commands, they require a bit of configuration, and we'll tackle that later when we have a real-world example. The last one that is available to us is the so-called isochronous transfer. And I must admit, before I was tinkering with USB, I've never heard that word before. And actually, those isochronous transfers are really rarely used. Usually, they're used for a constant stream of data, like from an audio device, like a microphone, or from a video camera. There is a persistent stream of data that you can grab or send. Bits can get lost, unlike with the two other methods. So basically, this is the UDP of USB, while the other two methods are basically the TCP of USB. We won't use that in our examples because I rarely haven't encountered them in the wild, and with rarely I mean never. So if you ever see them, consider yourself lucky. Now you know what they're for. And yeah, as you might see, I do have brought a few devices with me, and I think it's time that we can see what we can do with them and WebUSB in the real world. So my first demo involves, well, every tinkerer's darling device, the Arduino. I hope some of you have been to Theodore's talk yesterday about creating a Braille reader by using an Arduino. And we're not going to do something spectacular as this in this short demo, but I really encourage you to watch his talk if you haven't seen it later on video, because that was like a really cool tinker demo. Usually, when I used the Arduino with JavaScript, I used a project called Johnny 5 that existed also since 2011, and it is a Node.js-based project. So Johnny 5 makes it extremely easy to connect to many different microcontrollers, like the Arduino, and it has great code examples, great examples on how to wire things up, so that you don't grill your electronics, because everything is extremely well described, and you can just get along with the pictures they have in their demos and wire your things up. Well, now let's see if we can do the same from within the browser without Node.js. So, going back. Well, let's try to start with a clean desktop. Here I have an Arduino. Don't worry, I have a camera with me. You'll see it in more detail later on screen. And now I'm just going to, well, plug it in. And you see, I plugged it in, and a notification appears. It says, hey, I've recognized a WebUSB compatible device. And when I click on that notification, I am taken to a website. And you see, this is a live stream here. And now I need to connect to my Arduino Leonardo. Okay, I've already done so by accepting the notification that appeared. And I thought, okay, let's try and see if we can bring Johnny 5 to the browser and do that in an interactive way. So I have an interactive code console down here, and I've just trying to recreate the example you've all seen in the demos that I've showed on the slide before. So let's see if we can connect to this LED, which is on pin 13. And let's see if we can, well, turn it off, for example. So I'm using, we can also turn it on, right? it does work right away. We can basically use anything from Johnny 5 because it's running just in a browser as it does a node. So we can also use like the blink command, which then, well, makes the LED blink in a predefined interval. And yeah, basically, this is just the most simple demo you can get with Johnny 5, making an LED blink. But as we have the complete library in the browser now, you can basically do anything with it, like connecting sensors, displays, etc. Full-blown Johnny 5, full-blown Arduino control, without any server software, just in a browser. Right, let me quickly go back to the slides. Here we go. Right. So how have I done that? And I must say, it was actually quite simple. Using existing tools like Browserify, I only needed to specify a few node modules that I needed to swap out with its browser counterparts. Crucial thing here was the serial port connection. So there is a library on GitHub that has a fork that actually creates a serial port compatible interface in a browser using WebUSB, the browser serial port library. So it basically enables us to use plain old serial port communication commands from within the browser, from within WebUSB. And I think this is a good occasion to tell you more about this weird configuration we've seen a couple of minutes ago. Because in order to, this is just one command we're sending, one control command to open up the serial port connection initially. That is what the browser serial port library does for us. And it does this by using a control transfer out. First thing we need to configure in such a control transfer out command is the request type. There are quite a few. Class is basically a standard that is defined in a USB standard, because if you have a device like a printer or a card reader or a serial port device, they adhere to the USB standards, and you can signal that with the request type of class. Then we need to specify who we're going to talk to, and this special control command, we are going to talk to the interface. We could talk to the endpoint as well here. Then we just need to tell the device what we want to do. In this case, hex22, which means please open up the serial port communication. We could send a value along. Usually for opening up the serial port we don't, so we leave that more or less empty, so just send a control bit. And then we only have to specify the index, and with the index I mean which interface number we're going to send the data to. Actually quite simple if we think about it. So it's more like, okay, to whom are we going to talk to, what are we going to do, and well, that was it. So using this enabled me to use the exact same code as in Node.js, as in all of the examples of the Johnny 5 website, enabled me to execute this in my browser without, well, changing anything. I just needed to browserify and swap out the modules. And I found it quite fun and easy to do. Like, amazing. But hey, that was just one demo. So I have many devices here that connect to USB. And one of that is this cheap Chinese Android tablet. And well, as it also can connect via USB, let's see if we can, wow, connect from the browser to this Android device and, well, do something with it. I quickly just need to switch back to my monitor settings and sync the display so that you can see something as well. And okay, here we go. But before I'm going to do anything here with this tablet, that's actually quite cool because this device has a camera. And let me, well, take a picture of you wonderful people. Something that will remind me of my Moscow trip. Okay, done. And yeah, so I do have the camera, but oh, there's some, I want to show it to you, but it's quite, well, shabby picture using the camera and projecting that. So maybe we could just try and download that picture I've just taken to my browser. So the device is connected. Let's see, couple that. Okay, I allow this device to connect to my computer, or I allow the computer to connect to my device. This is the standard Android debugging prompt that appears, so it's connected. Let's see if I have any files in my camera storage. Oh yes, I have, because I've just taken that picture. Let's download, or try to download the picture. It's quite big, so it might take a while, but yeah, here we go. Lovely people. That are you? Well, I must say the camera of this device is a bit shabby, but I hope you've, well, just seen what I just did. So I used this device to take a picture of you and downloaded it immediately to the browser without using any server-side magic. But how have I done that? I've used the standard Android debugging bridge, in short ADB. So everyone who had to optimize some, well, either did native development or did web pages that also needed to run on Android devices is probably familiar with ADB. ADB is the standard protocol, and basically connecting to this device and downloading the picture just meant by taking that specification and turning that into code. There is some complexity in this protocol, and well, this is just a tiny part of it. Roughly one example that roughly illustrates how to construct a message to be sent to the device. And unfortunately, we don't have enough time to dig deeper into that. But if you want to do that, I can, well, refer you to WebADB.js, which is a full-blown ADB implementation that runs in the browser using WebUSB. Actually, that is built even by some people who work at Google. So it's like first-hand experience. And it makes connecting to an Android device from the browser as easy as this. I require the WebADB library. I connect to the device. And then I can do all wonderful things, like have full access, full shell access. I can upload APKs or download APKs. I can access all the user data, and well, that hopefully does ring a bell, because I mean, like, wait, accessing all the user data? Well, haven't those people thought about security when they came up with WebUSB? I mean, of course they did, because as said, if you want to connect a device, you can only do it via user gesture. The user has to grant permission explicitly to use this device by using the drop-down menu you've just seen. The WebUSB spec and implementation forbids to connect to cameras, microphones, or any USB storage devices, so you can't access those. And interesting thing, there seems to be also some kind of kill switch. So roughly a year ago with Chrome 54 or 55, they discovered the security flaw in one of the USB devices. The YubiKey, which is some USB device you can stick into your computer for two-factor authentication. And with WebUSB, it was actually able to, well, just download all the two-factor authentication keys, the whole table, from the device. And that was like such a huge security vulnerability that the folks at Google just kind of like flipped the switch and disabled WebUSB in all of the browsers out there. So no browser that was connected to the internet after they flipped the switch was able to use WebUSB anymore. And they only turned it on after they fixed the security vulnerability with the YubiKey device, because that is, especially in the US, a device that is widely used. And yeah, so there are a lot of security measurements, but I think some of the device vendors may have to catch up with those new standards a bit, because I still do believe like a good scammer could trick into connecting their tablets to the computer, opening a website, and yeah, activating ADB on their Android devices. But I bet even with tech-savvy and less tech-savvy people, it's, well, not easy, but possible to trick them into connecting the devices and, well, download all the data from them. So yeah, second demo, up to the next one, because I think it's the best thing to explain WebUSB is to see all the possibilities you have. Well, not all the possibilities, but many. And as I do work professionally in the field of smart home and like to tinker with smart home devices, I thought, okay, would be great if I could have like a smart home use case that I can bring with me. And actually I found one. So I'm using the Ocean protocol. The Ocean protocol is one of many wireless home automation protocols. I like it because it's extremely insecure and sends everything unencrypted over the wire, so it's easy to hack. And I'm using one of those USB dongles to, well, this is just basically a proxy or a transmitter that connects USB and enables me to talk to the wireless devices. And one of those is this, well, light switch you can just stick onto your wall to control devices. And I'm going to use that to connect to a bulb, a light bulb I have here, which is connected via the new WebBluetooth standard. So WebBluetooth standard is quite similar to WebUSB. I can't go into details, but when I'll upload and release my slides later, they will contain some links also to the best presentation about WebBluetooth from a friend of mine, from Niels. He's basically king of WebBluetooth. So if you want to get into that API as well, I can totally recommend that. I'll include that link later. But yeah, first of all, now I'm going to use this one wireless protocol, the Ocean protocol, and connect my light switch with it. And I'll use Bluetooth to connect to the bulb, and my browser as an interface between them. So my browser will take the commands I'll issue with this light switch, convert them into something this bulb can understand, and then hopefully we'll have a slightly cool smart home use case. There are quite a few, first of all, let me connect to that USB stick, great. And there are quite a few Bluetooth devices around here, as you see. So there's quite a lot of talk on the 2.40 gigahertz band Bluetooth is operating on. So I do hope that this will work. Okay, let's get that a bit sharper here. Here we go. So that's the light bulb. Here's the light switch. And I connected everything. And, well, it kind of does work. So I've turned off the light. Let's see if I can turn it back on again. Yeah, but it, well, takes some time. So I believe not all of the Bluetooth commands are actually, well, finding its way into that €3.5 Bluetooth bulb. So not the best hardware, but it actually does work, even if you press hard enough and believe hard enough. But yeah, so we can have a decent smart home use case with WebUSB and WebBluetooth, another, well, similar protocol, new protocol, which I quite like. And it's actually, well, it was actually quite easy because I already had this browser serial port library working for the Arduino example because I needed access to the serial port. And luckily, this tiny USB stick that talks the Ocean wireless protocol can also be used just via using the serial port protocol. And all I needed then was to listen on data, encode that data, which is just a binary blob, but I can use JavaScript's built-in text encoder feature to turn that into a string. And then I had to parse out the right part of the string, which in the end determines which button is pressed on the light switch, and if a button was pressed at all. So there are open source implementations also in JavaScript, but only for Node so far available for the Ocean protocol. If you want to dive deeper into that, hint, well, you probably shouldn't do because I think it slowly dies. But I just like it for hacking because it's so easy and unencrypted. Another thing with using WebUSB or using the serial part is it does not have a built-in event emitter. So like when I press the button on the light switch, I wouldn't have noticed that data is coming in from the USB port because the USB isn't designed in a way that it proactively signals to the computer, here is data. We always need to pull USB ports for data. And if you're a bit familiar with like examples in Arduino programming, etc., you probably recognize this. Well, this is a JavaScript version of it. This is a simple read loop. So we're basically pulling the device. There is the transfer in method. We're pulling the device constantly for its last 64 bytes of data. And when we got data, we emit it with our own event emitter, and then we call read loop function again, so that it's constantly running until there's an error, and an error could be that I just plug off the USB stick. That would be an error, and then the read loop will end. So one thing is really, you should really know when you start tinkering with WebUSB, no proactive data sending. You always have to ask, to poll, to ask the device for data. And, well, that already brings me to our last example for today. And I thought, okay, I have like this tinkering examples, like something to do with security with the Android, which is kind of useful. Arduino, which is also cool for tinkerers and having fun with devices. But is there really a use case for WebUSB? Something that is like that you can apply to the real world? And I think I have one. So we're building a public library, a checkout system for a public library. We'll have an RFID reader with that takes like this RFID cards and reads them out. So each RFID card is tailored to a specific person. That's mine. And then we'll use this wonderful device. I would, as a kid, I would love to have one of these, like this barcode scanners that they have in supermarkets, etc. So this is also attached via USB, and we'll use these to scan the barcodes of some books I have. And then we will use this device, which is a receipt printer. You probably know that from cashier systems as well, to confirm the checkout. Well, demo time again. So far, everything went quite well, so I'm a bit worried that this last demo will fail then, but let's see. So, okay, first of all, we have to connect to the printer. Why don't we have to connect to the two other devices? You're probably asking that to yourself right now. I'll explain in a minute after the demo. But yeah, every device seems to be turned on. Let's see, here we have the RFID reader. Let's use my RFID card to connect. Oh, sorry, I haven't shared the screen yet. Yeah, at least that happens. That happened just once. So let me quickly share my screen for you. I'm sorry about that. So here we go, now you see. So this is the RFID reader, and it's connected. So let's try to identify myself at this wonderful library system. Well, okay, access denied. That might be the wrong card. Luckily, I have another one. Let's try that. And yeah, access granted for the library user HolyJS. Good. Just a tiny sweaty moment there. Okay, so this is the printer we're using, and some of my most precious possessions. JavaScript, the definite guide. From 2002, it is the 4th edition, and it covers JavaScript version 1.5. So basically, this could be called JavaScript the forgotten parts. Still, I do like it. I could never throw it away, you know. And then I think I'll also try and use that book, Secrets of the JavaScript Ninja, last one by John Resig, which is also one I do really like. But let's see if we can scan that barcode here with a barcode scanner. Well, let's do this, and here we go. See, it's scanned. JavaScript, the definitive guide. Let's see if that works with the other book as well. Here we go, Secrets of the JavaScript Ninja. So I'm actually using a web API to fetch like all the details, like the titles of the books and etc. And the catch is that this 13-digit ISBN number is encoded in the barcode of this book. And when I have this ISBN 13 number, I can query that remote interface and ask for more data about the books. Which is kind of cool, because still, remember, this is all running in the browser, and this was the first time we used some external server system to request any data. But yeah, we're not done yet, because I want to like lend those 2 books. Let's print a receipt for that. And here we go. Oh, there's... You see, like, HolyJS rented 2 books, JavaScript, a definite guide, and Secrets of the JavaScript Ninja today. Thank you. So yeah, thanks. It's like you probably think, whoa, that is the last example, and that was most probably the most complicated one. Nope, actually that was the easiest one. So I was surprised myself when I got like this recipe printer for 15 euros from eBay. They're all adhering to a standard, POS printing standard. And all I needed to do was like connect to the device with WebUSB, use the text encoder functionality of JavaScript to encode a string, like a simple string of text. And then I used the transfer out method with the first endpoint and just put in the data, and then it actually does this. It prints the recipe. So I had done some more examples, so I can actually also use a canvas to print things on a printer. Not going to show that today, but this is also possible. But I was like really stunned and surprised how easy it was to like steer this old device that was, well, probably built years before somebody thought about WebUSB to control it with the browser. So that was simple. But for the other 2 devices, yeah, not so much, because the card reader and the barcode scanner, they belong to a special group of devices, HID, or human interface devices. Like all keyboards, mice, and pointer devices belong to this group, as well as many old devices that only need to transfer like chars, like numbers and text chars. So they just tell the computer, hey, I'm a keyboard, and then emit the ISBN number, the barcode contents, as like key presses, like a regular keyboard. Yeah, so there will be an extra standard aside from WebUSB, WebHID, that will cover these devices, but unfortunately it's not there yet. So the Chrome team is working on the WebHID API as well, but it's not yet in any browser. So you probably wonder, well, how did I get it to work then? Using one of the dirtiest hacks of all, because those 2 devices are just keyboards, I can listen to the global on-key press event, and please, don't do that, or, well, only do that if you exactly know what you're doing, because I only know one person who actually has something like this in production. I won't expose the person. But yeah, so what I do is, of course, I listen to the char codes that are transmitted, and the good thing is, as it's ISBN 13, if 13 characters are submitted, okay, I know I've scanned a book. All of the RFID cards emit a 10-digit ID, so if 10 characters are emitted, I know that someone tried to sign in. 13 are emitted, I know that someone tried to scan a book. And as the last character, those send like the return code 13, which is like hitting the enter key, so that I can then start to decipher what they actually sent. Horrible code, never use that in production, please. But yeah, thanks to the demo gods, that actually worked quite well. Well, better than some of hardware demo talks I've done in the past, at least. If you want to start tinkering with WebUSB yourself, if you want to start tinkering with USB devices, there is some built-in functionality in Chrome. If you type in your address bar Chrome -- device log, you see a log of all your attached USB and Bluetooth devices, and even more so. So the device log is your first go-to thing if you want to know what you need in order to connect a USB device, which vendor ID, which filter clauses you need to add, etc. If you don't have a USB device at hand, you can also fake one with the Chrome USB internals, which is another internal developer debugging tool where you can create fake USB devices that you can, well, test or use for testing and use for tinkering. So no real devices, those are emulated devices in the browser only. Okay, I've talked a lot about Chrome in this talk and only showed all my demos in Chrome. And you probably guess why. Because only Chrome and the Samsung Internet Browser on Android devices do support WebUSB so far. I don't think it's a big catch, because it's like a very special use cases you realize with that technology. So I think it's still okay to only have Chrome supporting it right now, because Chrome is available like cross-platform, even on Android devices. And yes, you can attach USB devices to Android devices and start programming them from your tablet, from your browser. And maybe Firefox will catch up rather soon, because in Servo they already implemented Web Bluetooth, and WebUSB might follow soonish. You probably won't see it in Safari in the near future. For Microsoft, for Edge, I don't know, to be honest. I should also mention that on NPM there's a module called WebUSB, which brings the WebUSB interface to Node.js. Which sounds a bit weird, because Node could talk to USB devices before WebUSB. But the thing is, you can reuse all the code, all the actually device drivers you've written with WebUSB in a browser in Node, essentially turning WebUSB into really a cross-platform standard. You can use it in your browser, and you can use it in Node.js if you install the WebUSB module. It's spec complete. Coming to the end. So you've seen quite a few examples, not that much code. What are the takeaways? First of all, WebUSB lets us, web developers, write our own drivers for devices. When I started making websites, I never thought I'd write drivers for devices. But if you interact with WebUSB, that is what you're actually doing. You write drivers for real hardware. We have great real-world examples or real-world things we can do, like building a checkout system for shops that works ad hoc. You only need to have maybe a barcode scanner, receipt printer, and an Android tablet. You connect those devices, you go to a web URL, and you can have a checkout system that maybe is directly connected to your warehouse system via REST API. No need to install any software. You just need to give the cashier this tablet, those two devices, connect it, and it works. No setup hassle at all. It makes it easy to start tinkering with hardware, because I had no background, no education in how to wire things up when I started with hardware. And actually setting all the things up, applying the right firmware to the Arduino, etc., writing C code in the beginning before there was Johnny 5, it was a big, it was a big wall I hit initially. And later on, being a mentor in coder dojos, working with kids up from the age of 5, they like to explore those things. They like to build things, but there was always the problem of setting everything up. Now that's gone. We just connect them, even if they only bring an Android tablet. We connect those devices and they can program them right away from their browser. We can write drivers that work in browser and backend systems right away because of the node module that we have, because of that interplay. I do hate the term isomorphic JS, but well, at least you probably all know what's meant with it. And I mean, the most important thing, we're improving the lives of the end user, because USB can be a shit show. But we, as web developers, can now make that USB problems go away. We can make USB live up to the advertisement and claims of plug and play it initially had. Well, I'd say second most important thing, because the most important thing is we as developers can have lots of fun, build shitty robots, and, well, yeah, just have lots of fun. I think just like the most important thing if you start tinkering with hardware and things like this as a web developer, as a developer in general. And with that, spasiba Moscow. Thank you very much for having me.